Powitajmy na scenie Przemka Szudera, dyrektora generalnego Amazon Web Services w regionie Europy Centralnej i Wschodniej.
Please welcome to the stage Przemek Szuder, General Manager for Central and Eastern Europe AWS.
Dzień dobry, witam Państwa. Good morning, hello Warsaw, hello Central and Eastern Europe. I have a real pleasure to welcome you here in the sunny Warsaw for the first ever edition of Central and Eastern Europe AWS Summit. Thank you for being with us here today. As this is the first edition in CEE, let me start by saying that it's not a sales and marketing event. This is mainly a learning and networking event. It's an opportunity for you to learn about AWS, to interact with our customers and our partners, and hear their stories about the journey that have with AWS technology. So feel free, please use every opportunity to also interact with each other, network, and discuss your ideas. We have over 2,500 attendees today. We will run over 25 technical sessions, and we have 19 sponsoring partners with us. Let me start by saying CEE region for AWS is 17 markets, starting with Poland and the north, and rolling down to Cyprus, Malta, and Greece. And it's absolute pleasure to welcome today participants from every single of those countries, alphabetically starting with Albania and Bosnia, and every single market is represented up to Slovenia and Slovakia. Again, thanks for coming. Many of you have made it a long way to be here in Warsaw. Welcome. But we also have a lot of the guests from other regions, notably from Eastern Europe, large representation from Belarus, Russia, Ukraine. Welcome again. We start the session with the keynote that will run until 11, and then at 11:15 we will begin the breakouts. There is one breakout room that may be particularly tricky to find. If you are picking breakout number 2, head to the main hall and go to the first floor in case you are lost. We will invite you for a lunch at 12, which is also a great opportunity to experience the expo area, talk to our partners, also visit AWS booths with experts from the partner team, public sector training and certification, and many others. I am wearing this t-shirt with the Warsaw Mermaid, which is the well-known symbol of the city. And this t-shirt is something that will help you to identify all my other AWS colleagues across the crowds. In case you have any question, in case you need any help, just feel free to reach out to us and talk. This summit is part of the global roadshow that's happening in many countries worldwide, and it wouldn't be possible without our global partners to be here with you today. So let me thank those global partners, which is Intel, VMware, Datadog, and Veeam, and also welcome their representatives today here at the venue. Let's roll the Intel video, please.
The world is a wild and unpredictable place. And isn't that absolutely amazing? Products can catch fire overnight. A back-of-a-napkin idea can change the world. An incurable disease can suddenly appear vulnerable. So many wonderfully improbable, never-before-possible breakthroughs are out there, waiting to be discovered. With Amazon Web Services and Intel, you'll be ready for anything. Ready to unlock a human genome, to safeguard our most valuable assets, to improve the way we communicate, to give every human a chance at a better future, to reach new speeds. Because you'll have Amazon Web Services featuring custom Intel technology to drive cutting-edge advancements. Because AWS and Intel engineers have worked together for over a decade to make sure you'll be ready. And because you'll have AWS's most innovative and powerful cloud service platform to help you make the impossible possible. That is the power of AWS with Intel. So go ahead, shatter conventions, explore the unknown, and ask questions that haven't been answered. With Amazon Web Services and Intel, you can charge toward the future ready for anything and ready to change everything.
I also want to use the opportunity to thank our all local and regional sponsors, particularly the platinum ones, which is PGS Software, SignalFX, and Veeam, as long as welcome all the gold, silver, and training partners that are with us here today. Central and Eastern Europe is the region that is well known from the academic and engineering talent that we have across the countries. We are home as an area to more than 1.4 million of the developers, so it's not a surprise that AWS presence is really strong here with our development centers in Gdańsk, Bucharest, and Iași. You will hear later during the keynote about some of the work that is taking place across these sites. At the same time, we are constantly growing and expanding our teams. We are increasing the different roles across the markets in Central and Eastern Europe, and even today, we have almost 30 open positions for AWS in CEE. We are also constantly looking for new partners. There is already over 800 organizations that partner with us in Central and Eastern Europe, but we keep looking for more. So if you are today representing either the consulting business or the technology business building your own IP, and you want to explore the partnership opportunities, it's a perfect idea to visit the partner booth and talk with us about what we can achieve together. With the growing platform of AWS and growing amount of services, and at the same time, the number of projects that are happening in the market, cloud skills are as important as ever. We are committed to increase the cloud competencies across the market, both through our training partner network, but also through our direct training and certification engagement. Last but not least, in Warsaw, we have opened AWS Global Competency Center, which will help our customers across Europe, but not only, to build cloud-native applications using microservices and serverless technologies of AWS. The consultants based in Warsaw will work both remotely and on-site, helping our customers and our partners to use the AWS platform potential. We have already earned trust of tens of thousands of customers across Central and Eastern Europe. And what you can see behind me is just a snapshot of selected companies from different industries, different customer types, and different markets across Central and Eastern Europe that has trusted AWS. And let me give you a few examples of how these companies are using our platform. LOT Polish Airlines, one of the oldest airlines in Europe, is using AWS as an internet booking engine across mobile application and website. Then there is Innogy in Czech Republic, which is part of the Innogy Group and one of the largest energy providers in Europe, that has migrated its SAP warehouse from Oracle to run SAP HANA on AWS. Then there is Beat, a ride-hailing company based in Greece, which uses AWS to run 10,000 of passenger rides per hour across Central Europe and Latin America. Again, it was built on AWS from day one. Finally, we have Vivid Games in Poland, the company that is behind Real Boxing, which had more than 50 million downloads, that runs on AWS since its inception. You will hear more of the customer stories throughout the day. Again, thanks for being here with us, and please join me in welcoming our Chief Architect, Glenn Gore, on stage.
Wow. Good morning, Warsaw. How is everybody? Good? Man, what a turnout for the first summit ever. I have to say, in my role, I get to work with developers and engineers all around the world, and I'm always amazed when I meet people, no matter what country. They're either Australian from where I'm from, or they seem to be from this part of the world. And so it's an absolute pleasure to be here today to share with you some of the latest trends and thought leadership that's happening in cloud, technology, and innovation in our industry. And so if you think about what AWS has been doing over the last 13 years, one of the key themes has been we listen to developers all the time. Actually, 95% of the innovation and feature requests that we do come from you. We listen to how we can make things more simple, how we can help scale the platform, where you want to go, how do we innovate on your behalf. When you look at this innovation, it's led to the broadest and deepest platform of services that exists in the industry in the world of public cloud. Over 165 services today, and it's growing all the time. Now, I'm not going to go through all 165 services as much as I'd love to do during the keynote. We'd be here for half the day. But what I'm going to do is, I just want to kind of drill into a couple of key areas that I think are really important for everybody. And the first one of these is the global infrastructure that AWS builds upon. We have 21 regions around the world. And the best way to think about a region is a collection of availability zones, which we have 66 of those. Most of our regions have 3 or more publicly accessible availability zones. An availability zone, think of that as a collection of 1 or more data centers. So that as you distribute your applications and you build them and you spread them across availability zones, you know that they're going to be highly available in an active configuration. And because they're within a region, for example, let's say Frankfurt, you know that your data is safe and secure in that Frankfurt region, and it stays in that Frankfurt region. We don't copy it, we don't move it. You can choose to move it wherever you like, but we don't do that. And so it's really important when you start looking at security measures, GDPR, for example, and regulated industries. It's really key. Now, these regions around the world, they're backed up by edge locations, of which we actually have 2 here in Poland, for example. And they're connected by our own backbone, which again allows for safe, secure, and fast connectivity between those regions. What about databases? We hear again and again from developers that you want a lot of choice and flexibility and freedom in how you work with data and how you store that. We have 14 different database technologies you can pick from, and I'm going to go into these in a little bit more detail. But these are purpose-built for different workloads, and one of the great things when you're using AWS, because you pay as you go, you can experiment. You can use one type of database technology today and easily migrate to a different one tomorrow based on the scaling and your own needs as they change day to day. We also have the database migration service, which allows you to convert between schemas even. You can change from database engine to database engine, even from NoSQL to SQL if you choose. So very, very powerful. Now, underlying all of this is you need storage. You actually need really, really robust storage to store important information. You want to have choice again. Do I want block level storage against my EC2 compute instances, for example? Do I want to have an object store that's infinitely scalable and high performance? Or do I want shared file access, where I want to share the same content across my services? Really useful sometimes in high performance computing applications. You might be using, for example, Lustre file system. Or what about data transfer? No point having all this storage if I don't have a way of transferring information in and out of AWS and between my different services. So we have 11 different ways that you can migrate that. We're going to come back and touch on those in a little bit more detail. And security. There's one thing I've learned over decades of being an architect, is that if you don't start with security as the foundational layer, You don't have a secure application. You do not have a secure environment. You can't come and wrap security around after the fact. The horse is already bolted, so to speak. And at Amazon, we take security, it's our job zero. We take this incredibly seriously, not only internal to Amazon Web Services, but also how we provide this to tools to you. For example, we have over 200 security services and features across AWS that you can use. That's more than any other vendor in the cloud industry. We have 116 different encryption technologies, 3 times more than anyone else. And if you're using encryption, you want to have a safe and secure way to manage keys, particularly as you start using industry best practices in your data lakes, for example, where you want to use rolling keys. Every file, every customer has their own key. You start now managing tens of thousands of keys. The key management service, or KMS, becomes really key. So that you want to have that integrated to services as well. So we have 54 services integrated with KMS, 4 times more than anyone else. So this is really key. These kind of just these couple of areas that I picked on. We're going to dive into more over the rest of the keynote. But one of the areas I want to focus on first is how do I get my applications and assets into AWS in the first place? We've been listening a lot to not only big enterprise, and these enterprises can be global nationals, they can be mid-size organizations, even sometimes SMBs who just have 8 or 10 servers and they want to move to AWS so they can get cost savings and agility in they do. So how do we help customers move even faster to AWS? Well, the first way we do this is through data transfer and storage and giving you lots of options. For example, if you're a large enterprise with your own data centers and high-speed networks and you want to be moving petabytes of data between AWS, one way you may want to use that is using Direct Connect, the ability to have a safe and secure network connection directly from your on-premises networks to AWS, terminating directly within your virtual private cloud networks, or VPCs. Or you may not have the luxury of being in a location where you have fast Direct Connect network access. So you might want to use something like Snowball, which is a physical device that we can ship out to you. You plug that into your local network, transfer your data safely across. It's encrypted, it's GPS tracked, ship it back to us, load it up in the region. Very, very, very fast way. There's always that joke that nothing beats data transfer like a car or truck full of disks, and that's still true today. There's storage gateway services, for example. AWS Data Sync is a really cool tool that you can use, which is kind of like rsync or robocopy, but 10 times faster. And so again, this gives you a lot of choices, developers. What is the right way to migrate data in your storage for you? We're not going to dictate that to you. And this is, again, why it's really important to have the flexibility and freedom of choice for you to experiment and innovate. What is the right tool for your particular use case? There is no single one tool that rules them all. And you're going to see this as a reoccurring theme through this. We touched on database migration already. But one of the things to say is this tool has been used already to migrate over 130,000 databases to date already. So if you're looking at, for example, you're on different database technology and you're looking at how you can run this in AWS, this is the easiest way to run it. Now, it has lots of features in it as well. You can do rollbacks. It's got lots of features. And as I said, you can do schema conversion within it as you go through with this. Well, what about applications? SAP is very popular in enterprise. We've been having a very close working relationship with SAP since 2011, where they certified AWS as a provider for their software, for their applications and database technologies. We also see Windows up there. And actually, you'd be surprised to learn just how many Windows workloads run on top of AWS. We actually have hundreds of thousands of customers running their Windows workloads on AWS. We launched our first Windows workload back in 2008. And according to research by IDC, who's one of the world's analysts in this space, we host 2 times as many Windows Server instances as Microsoft does themselves. Scale matters. Okay? Choice of tools and the environment that is around the EC2 instances that you're running matter. This is why breadth and depth is so key to building well-architected solutions in the cloud. Running these services for the last 11 years, we've built a lot of trust with our customers. For example, Autodesk has been running all their server fleet is largely on Windows. Or if you look at Salesforce, for example, they're running over 10,000 Windows instances on AWS, one customer. And they use all of the tools that are being built around to help them manage that. Patch management, back it up, service management. There's a lot of features that have that to make it easier for them. But what about hybrid? Now, if you don't know what hybrid is, the best way to think about it is you have at the moment, for a lot of organizations, have their existing on-premises data centers. You may have one, you might be in co-location facilities, you may have multiple data centers. And kind of the bigger you are, as much as you may love to go all in on AWS, it's going to take time. For some organizations, it's going to take many, many years because they still have their own business to run. They may be running in a regulated environment where it requires quite a lot of work to go through and get approvals for each new workload. And so when you think about hybrid, we look at this and think, well, what can we do to help customers manage both the environments that will be running in those on-premises data centers for what could be foreseeable for the next 5+ years, but as well as the applications environments that they're running in AWS at the same time. And that's hybrid. It's the combination of the on-premises with your AWS workloads. And so we have a couple of things here to make it easier for you to manage your environments as you're in this transition period. We talked about Direct Connect. And this is really important. It's not just about having a safe and secure network between your on-premises data centers and the cloud. This becomes important, for example, what methodology do you have as to which applications do you move first? You may be using AWS, for example, to do overflow. Let's say you're having bursty traffic or unexpected traffic, and you just need more capacity, but you need it very quickly, and you don't have the capabilities in your existing data center to add that capacity. Use Direct Connect to use the resources in AWS and burst up. When you're not using it, turn it off. Don't pay anything for it. This kind of flexible, on-demand, scalable pricing works. You have Snowball Edge, for example, that little physical device that I was talking about we can ship out for storage management. You can also get the Edge-enabled version, which has compute in it. And so you can run Lambda functions, for example, in Snowball Compute optimized. We have AWS Outpost, which we announced at reInvent last year in December in Las Vegas. What Outpost does is takes physical infrastructure similar to what we run in AWS, which is kind of the compute storage and a bit of networking, and you can now run that within your own facilities when it's released to general availability. This is important because you'll be able to now have the same APIs on premises that you do in the cloud, which is going to make it a lot simpler to migrate. You'll be able to use some of the new features around your CI/CD tool chains, for example, on premises. As you move to AWS, it'll be completely seamless. What about VMware Cloud on AWS? The majority of virtualization out there runs on VMware today in enterprises. And we're really proud of the relationship and the partnership we have with VMware that we've been building for a number of years now. Actually, we're the only managed cloud provider to directly support and operate VMware Cloud outside of an on-premises environment. We've been using, continue to innovate in this space a lot. For example, Outpost that I just talked about, this ability to take AWS hardware and run this within your own facilities. We're going to be releasing a VMware version of that. So not only will you have the choice of do I want to run AWS APIs on Outpost, but do I actually want to run VMware on it in a bare metal version, for example. And so this is a really important part. It makes it really easy for customers who already have their existing VMware workloads to make choices in this hybrid world of how best to manage it regardless of where the workload is running, whether it's still within the on-premises data center or with its AWS. And again, why? Because it starts off with that very first statement I said, which is we listen to you and we take your feedback, which is you want the choice and freedom to make your own decisions. You don't want to be locked in to a decision that may not be right as you learn more about it. So with that, it's my absolute pleasure to introduce to the stage our first customer this morning. This is a customer that actually started their migration journey to AWS back in 2014, where they started with disaster recovery, which is a very common place for customers to start. And in 2018, they've really started migrating their on-premises workloads to AWS. So I'm really excited to have here today the Chief Executive Officer from Ringier Axel Springer, Mark Dakan here. But before he comes to stage, we're going to play a quick video just to introduce what Ringier does. Thank you.
Hello, good morning. Dzień dobry. Pleasure to be here with you. Ringier Axel Springer today is the leading digital publisher in Central Eastern Europe and also in Poland. In Poland, we run Onet, the largest news portal of the country, and it's also our leading brand. And being a media company today means also to be a tech company. We got a fantastic development center, DreamLab, here in Poland, but DreamLab is also our development hub for the entire Central Eastern European region. DreamLab has, long before moving to the cloud, already platformized all its solutions into one digital publishing ecosystem called Ring Publishing, and we run Ring Publishing for over 50 content brands across Europe. And I mention this because we have a tremendous history in development, a vast experience. And interestingly, this experience was at once an asset, but also, to some extent, a burden. Because you should know that we as a company, we used to develop literally everything ourselves, and in many multiple versions. And to become more specialized, modular, and to integrate also external solutions into our tech stack has been and still is a key challenge for us as a company. In that context, as you can imagine, to take the decision to move, to migrate to a cloud technology has also been a very emotional decision for us. It meant to abandon our past, our heritage. I mean, we had our own on-premise network. We run our own data center. And naturally, we have been very proud of what we have accomplished over all those years. Nevertheless, we couldn't close the eyes in front of reality and had to face what's happening around us. And the world was changing fast. Business needs were escalating at record speed. We also found it tougher and tougher to acquire the right talent on the market for our own developments. And hard to admit, but cloud services have set new market standards, literally, across the whole market. And I mean, particularly here, their range of functionalities, which were exploding. And for us as a company, it was very tough to match this range with our own development. It was literally impossible. So, slowly but surely, we risked, with our own on-premises solution, to lose market and business potential. So, what to do with that? I mean, we took the only right decision, and that was to go all in on AWS. And all in for us means, in that regard, that we really moved all our content services and big data stack in an AWS environment. We started that already in September 2018, and we would like to complete that task within 3 years. And for us, it was never really a question if to do that, but when to do that. And for us, the tipping point we figured out was end of 2019. This is basically the moment when we calculated that the cost of our solution would go above any cloud technology. So we anticipated that and started the journey already in September 2018, last year. So if we do something, then we also move fast. We have seen already some significant progress on that. Already by the end of this year, we will have switched off 50% of our own hardware. Already today, we have moved all our content services to the S3 Amazon storage in Frankfurt. And if you take such a fundamental decision, then we really go all the way. We have also taken now the decision to dispose of our own data center. So why AWS, you might ask, and why not another cloud solution? And there were, of course, numerous factors that were impacting our decision. One was, as Glenn mentioned, familiarity and compatibility. Because already in 2014, we started to use the discovery, disaster recovery plan on AWS. So we had an experience, our developers were familiar with AWS environment. At the same time, also some key elements of our on-premise solution was compatible with an AWS environment. That definitely mattered. But another aspect also was that it followed a commercial logic. We were offered actually a very attractive program, so it made also financial sense. But these were factors we took into consideration. The ultimate truth why we went for AWS, however, lies in the fact that it has been the clearly preferred solution for the vast majority of our developers. So, if we have learned one thing in the past as management, then not to go against the strong recommendation of your tech teams. At least not unless you have a really compelling, meaning bulletproof, reason to do so. So, to cut it short, the naked truth is that the decision to go for AWS has been taken by our developers and not by management. Business impact. What do we as a company expect from this migration? So we have, of course, big expectations. First of all, we expect to significantly decrease our total cost of ownership in 5 years. Also, we expect to release resources which we can invest in new areas from infrastructure savings. And here we see already very promising results. Only with the savings we have achieved so far, we were able to really double the investment in new areas. And last but not least, we are now able to focus the attention of our developers on critical areas, gaining substantially more business value in areas like AI, machine learning, automation, you name it. Also interesting for us, moving to the cloud enabled our digital publishing platform, Ring Publishing, to reach a completely new level of maturity by accessing cloud technologies. And that enabled us to now offer our solution also to third parties. We have become competitive to offer our cutting-edge media technology platform as a software as a service on the market, and through this tap also new revenues. For me as a CEO, what has been really surprising throughout that project was actually how quickly our developers got up and running on AWS. With only 1 day of dedicated AWS training, our teams went into an AWS Hack Day, and we have seen really impressive innovations coming out of that. For instance, a personalized lead generation for e-commerce, or an AI-based automated content creation. So really very promising innovations that create tremendous business values. So that's definitely something I have been particularly amazed of. So to conclude my short speech, let me also share with you what are actually our learnings, our takeaways, which could be valuable for you considering a similar approach. So first of all, I have to say, migration to cloud is not a tech topic. It's a fundamental cultural change. I mean, you move from a CapEx to an OpEx environment, you pay as you use. You at the same time have to face that everything becomes platformized. Costs are fully transparent to the bottom. There is no place to hide anymore in your organization. And of course, such a migration might trigger other potential changes. And you really have to be prepared for a continuous transformation. Secondly, it's vital that you recognize that different skills and processes will be needed in your entire organization for the future. And that this means structural changes and a tremendous change for your people. That's very important from a psychological perspective. You have to understand that this is a change project, meaning you have to manage it as a change project. That has a particular impact for your communication as a leader. You need to really see how you as a leader look at change. For me, curiosity in new things has always been a key essence in human nature. The success of our species has always been largely dependent on our ability and willingness to engage with and master change. And I say this because from a leadership perspective, it is absolutely success critical that you communicate this change as a positive evolution, and that you credibly communicate to your people your deep desire that you want to make them the fittest to survive in this challenging, fast-changing VUCA environment. And of course, communication is just words. You have to match your words with actions, because this, at the end of the day, creates the trust you need to succeed. So what you ultimately have to do, you have to invest. Invest in the development of your people, training, coaching, give them all the support they need so that they can really succeed. And if you do this, you build, as I said, trust. You also build loyalty. And in the end, you retain the talent for the future. And interestingly, change, which very often for many people has a negative meaning in the first place, all of a sudden becomes a real leadership opportunity, a positive platform to build sustainable success. So, thank you very much for your attention. Enjoy the conference. Great to be here with you.
Awesome. Thank you, Mark. What Mark was just talking about couldn't be more true. I'm a geek. I love technology. I could talk technology all day, every day. People complain about it. But the reality is I spend more time talking to customers these days about culture and organizational change, because tech is just the enabler. It's just a small part of that overall piece. And I think Mark's words about as a leader, setting that vision and communicating it is really key. But for those of you who aren't leaders, and you kind of think, well, I'm just a developer, I'm just an engineer. Well, you actually have a leadership role as well. You might not realize it. But you're also just as important, because leaders need great advice and people who can be creative problem solvers to help guide them to achieve the visions that they want to do. Let's talk about databases again. We already talked about it a little bit, but I want to this time talk a little bit about one of the trends that's happening, which is this migration away from kind of legacy enterprise databases. Now, something I hear from customers a lot, particularly where they're using Oracle or other kind of very traditional, very expensive, locked-in databases where you get audited and you get fined if you didn't use it exactly the way that they wanted you to do, was they hate it. it actually stifles innovation within them. And this is what's driving a huge shift towards open source technologies. MySQL, Postgres, MariaDB, for example. And one of the ways we looked at this was, how can we take the best of what open source provides, but there's also these enterprise needs that these enterprise databases actually provided. Extremely high fault tolerance, high availability, security features, extreme performance needs. And so we looked at this and said, well, how do we take all this and what we've learned building cloud-native applications and services and combine them together? And this created Amazon Aurora, which is our kind of version of what a database should look like when you build it natively for the cloud. Not take pre-cloud databases and try and get them to fit there. And when you do this, you can do some pretty amazing things. First of all, it's fully compatible with MySQL and Postgres. So all of the tools, the frameworks that you know and love, work with Aurora. No change required. Your schemas work. No change required. But it's 5 times faster in the case of MySQL, 3 times faster with Postgres. It's highly available and durable. It automatically scales across the availability zones in the regions that we talked about. You don't have to worry about the undifferentiated heavy lifting of how to run clusters, replication, all that kind of hard stuff. You don't have to worry about it. It's a managed service from AWS. We do that for you. As a result, it's highly available and durable. It's actually got 4 nines of availability to it. But best of all, it's 1/10 the cost. Not only is it 1/10 the cost, but you can turn it on and off to your heart's desire. You don't have to be locked in for a multi-year contract for some guess as to how much capacity you need. You can dial it up and down to your heart's content, in and out. And so this gives a lot of freedom again for you to start using Aurora. And there's actually some features there. You can use Aurora Serverless, for example, which gives you new capabilities as well. But if you look at this, as a result of just how painful it has been for people to work with databases, Aurora is the fastest growing service in the history of AWS. Now, every couple of years, a new service gets to claim this title, but Aurora has actually been hanging on to this now for a couple of years. And tens of thousands of customers are using Aurora today. It's been growing at 2 times over the last 3 years. Dow Jones in the US, for example, they shortened their nightly load times of market data, which is a huge amount of information, from 8 hours to ingest it down to 3 hours, just by shifting to Aurora from their existing legacy enterprise database provider. Huge savings that can be made here. And again, if you're not using Aurora and you're using other database technologies in AWS or other providers, it's okay. Just use the database migration tool to migrate when you're ready to. Or you can migrate back off again if you like to as well. It goes both ways. So when we think about databases, we can kind of lump the databases together in a number of different families. We have our key value stores. This is kind of the traditional, what we call NoSQL model. There's not really a lot of relational there. You have document databases, which is Amazon Document DB. In memory, where I want really, really high performance at ultra low latencies, often measured in single-digit millisecond response times. Elasticache, for example, Memcache, Redis. I want to have graph databases. Really important, for example, if you're trying to create social networks. Neptune allows you to build graph databases at scale. Time series databases. One of the big changes right now in the world of IoT is we have billions of devices streaming data to us, but that data isn't always in the right sequence. Gaming companies use time-based sequence data to work out how people are playing games and how to tune and optimize those games. But you can imagine if I'm playing my mobile phone and I get on that plane back to Seattle tomorrow, there's about 10 hours where I have no internet connectivity. So when I land, it's now trying to synchronize 10 hours of event data, and the gaming company's trying to slot that back in the right order so they can get stats and analysis as to how their customers were playing that game on a true hour-by-hour basis. Time series databases are very, 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 very good at dealing with that type of information. which is actually incredibly complex to structure correctly within a relational database model, for example. And finally, but not last, ledger databases, or blockchain-based technologies. So let's just dive into a few of these. Amazon DynamoDB. This has been around for quite a while. It underpins some of the biggest websites out there on the internet today. And DynamoDB, while it's been around for quite a while, we've been innovating constantly at it. We announced global tables, the ability for you to replicate your data across multiple regions. You get to control that. What about on-demand backups? Even if you have terabytes, petabytes of data in DynamoDB, the ability to back it up and have no performance penalty as a result. There's no taking that database offline while it's doing its backup. It just takes a snapshot and keeps going. There's no point having backups if you can't do point-in-time recovery. What happens if I make a mistake and I need to roll back to a particular time? DynamoDB supports this. And last but not least, for those of you who may have been using DynamoDB for a while, it was one of the few services we had to specify capacity in advance. And now you can have it on demand, so it scales like a lot of the other AWS services, so you can set your limits, and away it goes. Amazon DynamoDB is really great, for example, for session data on databases, for example. User information, things that are relatively simple, but needed at high transactional volumes. And it's reliable performance at any scale. It's incredibly proven. There's some good example customers here. Locally, in this part of the world, CodeWise provides software as a service performance marketing solutions that helps media companies buy. Actually, there's about $1 billion of ad spend that they support, over 300 billion visitors every year. I mean, these are huge numbers for their business. They use DynamoDB at the core of their application, supporting tens of thousands of bids in the ad world, so you kind of bid on whether you want to pay for that ad spot on a web page or not, per second. I mean, this is huge transactions, tens of thousands of transactions per second. But what I love best is their engineering team spends 95% less time on engineering troubleshooting problems with that database. It just works reliably for them. Epic Games. They use DynamoDB to do their real-time and batch analysis analytics in their games at over 125 million events per minute. I mean, the scale that these things are running at is incredible. It's only going to increase over time. What about blockchain? There's a lot of buzz in the industry about blockchain right now. You hear it all the time, and people get blockchain and cryptocurrencies kind of mixed up. They are separate things. We just talk about blockchain. And we heard from customers, there was kind of two types of blockchain implementations they wanted to have. The first was they wanted to have a centralized ledger. And the second was they want to have a distributed blockchain model for that. So let's look at these. The first one we have is Quantum Ledger Database, which we announced last year. And it's a fully managed ledger service that's cryptographically secure. So it's immutable. It append only data to this as it goes through. It's cryptographically verifiable. So you need to be able to prove that the ledger is accurate and hasn't been modified as it goes. You want to make sure it's got integrity. And it's transparent. Customers have full visibility of their entire data lineage as this goes through. Who made changes to that ledger? And customers can come back and easily track and analyze each change for the entire history of that ledger. This is really, really important when you're running a centralized ledger. We also have Amazon Managed Blockchain, which is create and manage a scalable but distributed blockchain technology base. Available right now, today, generally available, it's based on Hyperledger Fabric, and coming soon will be Ethereum. So there's two really popular choices there for you to build upon. And it scales to support thousands of applications running millions of transactions. So this is still in preview. This is out there. You can create blockchain networks with a few clicks and manage them with simple API calls. So the same features that you have for other services, you have available to blockchain. Remember I talked about encryption and key management services? It's all tied into blockchain. It's integrated into the AWS ecosystems. This is really powerful things. So I think we're just at the start of what developers and engineers are going to be able to build out of some of these technologies. But being able to democratize and make it easier for you to get started, because running a distributed blockchain in the past required a lot of effort, a lot of engineering time to stand it up from the scratch versus a couple of clicks on a mouse button. And so when you look at the depth and breadth of purpose-built databases offered by AWS, there's really never been a better time to be a developer given the choice that you have. Now, you might be looking at this and wondering, well, how do I get started? How do I know which database is right? I think one of the great things right now is, to a certain degree, it doesn't matter at the start. If you're just starting off building something, experiment. There's this great quote by Joy Oito, who was the head of MIT Media Labs, which is, if you want to increase the pace of innovation, lower the cost of failure. One of the ways to lower that cost of failure is by not being locked into your technology decisions, reducing that technical debt that you have. And all of these services, you're in control of, API-driven. All right. So if we talk about databases, well, on top of databases, you want to build applications. And one of the big trends right now is microservices. And if you look at how we used to design applications from an architectural perspective, we often deploy them as monoliths. One single big, fat application. You're lucky if it had a couple of different components on it. And this it was a nightmare to update. If you're a developer writing code, you were making changes to a very large code base that was incredibly hard to test. If you're an administrator and you were trying to deploy this, those change management windows, you're often rolling out 70 rolled up changes at a time to that one application. And if one of them failed, you rolled the whole thing back. This is kind of what led to this kind of frozen ability for IT to keep systems up to date. What microservices does is we start taking that monolithic application and define the service boundaries as to what are the unique components within that, what are repeatable maybe even across our business, and let's break them up so that each microservice does one little piece of the function. But together, you can do some incredible things with it. Now, when I think about a microservice, a common question I get asked is, well, how big should a microservice be? And the simple definition I like to use, if it takes a single developer more than 2 weeks to rewrite the microservice, it's probably not a microservice. And you want to just kind of use that as time. Now, these microservices can evolve over time. It's okay. They're relatively lightweight, and as they go through this. Now, as you run your microservices, what are you going to run them in? Again, you want choice as to how the compute layer that underpins this and gives it the horsepower to run works. And you can think about it as there's 3 options available to you at a macro level. I can have kind of more traditional EC2 compute. Your operating system, compute, memory, storage attached to it. I can have containers, an ability to package up my application environment and allow me to move that across servers and operating systems without having to worry about libraries and some of the dependency management, for example. Or you have Lambda, which is serverless. I just want to deploy my code function and not worry about infrastructure at all. And so they're the kind of the 3 big choices you have available to you. Now, it's quite common as developers and engineers that you may be using combinations of all 3. It is not a case of one of these trumps everything else. When you have hundreds, if not thousands of applications, even hundreds or thousands of microservices in the fullness of time, you'll find that you'll want to optimize based on which one of these 3 decisions to get that right cost optimization for you or the level of availability and performance you need. So let's just dive into these in more detail. If you take compute, for example, there are over 200 choices available to you today, ranging from Intel-based CPUs, AMD, or ARM-based instances, which are really good for kind of scaling out horizontally workloads. But what I love is if you look at the performance available to you today, compared to the very first EC2 instance, that we ever launched. The first EC2 instance had one CPU, 1.7 gigabytes of RAM, 160 gigabytes of local disk, and 250 megabits per second of network performance. Today, the largest EC instance you can get comes with 12 terabytes of RAM. And actually, we're growing that to 24 terabytes later this year. Or to put that another way, the largest EC2 instance you get today is 10,000 times bigger than the first instance we ever launched with. And that's amazing. There's just kind of growth of services as you go through. And whether you're running HPC workloads where you want access to special CPU types, FPGA-based technologies in our F1 instances, for example, you want to be doing machine learning and using access to GPUs or our P3 instance family, which we'll come back and talk about in a little bit more detail. There is lots of choice there for you. And again, if you're looking at this going 200 instance types, maybe that's too much choice. Experiment with it. Use different instances. Work out what is your best bang for buck. Now, underpinning all of this, there are different financial models that you can pay for your compute. You can pay for it in the relatively simple on-demand model. I just pay per hour, per instance. It's fixed, it's predictable, it's easy. Or maybe I'll use spot market, for example, where I can bid on the capacity that's free in AWS and sometimes get instances at less than a tenth of the normal cost. And so this can be really good for speculative workloads, for batch processing, for example, where you can have workloads that start and stop, and it doesn't matter. It's a great way to bring costs down. It's used by a lot of companies, for example, pharmaceutical companies doing big chemical compound analysis, for example, overnight. Or media companies doing re-encoding of video content, for example. They use spot market heavily. Or if you know that you're going to use that instance type for the next year, what about a reserved instance, for example? These can have huge impacts on the costs of your compute family. What about when you talk about the container services? When you think about containers, a simple way to think about it is there's an orchestration layer. And you can choose between ECS, kind of based on Docker, or EKS, based on Kubernetes. Underneath that, I have my compute engine, which could be EC2 we just talked about, or it could be using AWS Fargate, where, again, as a managed service, we'll take care of managing the compute capacity on your behalf. You just worry about the containers. And underneath all of that is I need a repository of where do I store my images. And that repository really shouldn't get in the way of me developing new services or my tool chain as a developer. So this is how we go through these case by case. So Amazon ECS. This is often the first choice for customers who are looking to get started in containers because it's built as a core primitive in AWS. It's the one that's most integrated with all the AWS services. It's available in every single region around the world and has lots of capabilities. It's integrated to VPC, for example, the virtual private cloud that allows you to have a secure environment within AWS where you're in control of networks, for example. You can integrate it with application load balancers, network load balancers, CloudWatch for monitoring. It's very, very well integrated. So if you're using this, it's great. It's got auto scaling, advanced task placement. There'll be breakout sessions going into the container services in more detail. AWS Fargate, which I talked about just earlier, what it allows you to do is kind of like serverless, but for containers. It allows you to not have to worry about the EC2 instances underneath or what availability zone they're running in or what it's made up with. You just look at how many containers do I want to run and how do I want those containers to scale over time, and Fargate will take care of the rest for you. And there's tens of millions of containers run for customers every single week on Fargate. And then we have EKS. Now, Kubernetes is incredibly popular, particularly if you've been running containers in your on-premises data centers. It's been very, very, very popular. And so we've looked at EKS, and we're really proud of the work we've been doing there. You can see here some of the features of it. For example, we try to keep it in sync with the major version releases. But one of the things that I like is that if you're looking at this and thinking, well, I'm going to be running Kubernetes on-premises and in AWS, I don't want the two to divulge. Well, that's where we talk about it's been 100% upstream Kubernetes. So as AWS, as we look to make changes to how Kubernetes works and some of the features that we think it needs in the cloud, those changes will be pushed upstream so everybody gets the advantage of it. And this is the value of open source communities and why Kubernetes is so important. If you look at customers are doing amazing things in production with containers. For example, again, here in Warsaw, NetHome, for example, they offer a PCI-compliant business intelligence and fraud prevention solutions for travel, digital lending, and e-commerce industries. And they use Amazon EKS to manage hundreds of Kubernetes containers that form its fraud prevention toolset. And by running their containerized environment on AWS, they've seen a 50% reduction in the time it takes for them to practice DevOps. Again, that means more time for them to innovate and add new features and services for their customers. Or McDonald's. We all know McDonald's, the big restaurant chain. They launched a home delivery service in 4 months by using microservices-based architecture running on Amazon ECS. And this cloud-native microservices architecture allows them to process 20,000 orders per second. That's a lot of Big Macs and French fries. 20,000 a second at less than 100 millisecond latency. So again, high performance, high agility, the ability for these customers to experiment and use cutting-edge technologies as they go through with this. Serverless application architectures in AWS. We talked about Lambda, but what you might not realize is there's a lot of other services that fall into what we categorize as serverless. S3, for example, our simple storage service, is serverless. You don't have to worry about the underlying compute. Cognito, for user identity management. It's a managed service. You don't have to worry about compute. You can see there's this trend over time to move towards higher valued services where it's more of a managed service for you as the customer so that you can focus on what's important to you. There's communications, there's a whole selection of things. This is just going to grow over time because once you go to serverless, to be honest with you, it's really hard to go back where you're doing OS patch management, installation, and all that kind of heavy lifting under the covers that, to be blunt, doesn't add a lot of value as you go through with this. So serverless is really powerful. And again, customers from all industries are running serverless all around the world. In Krakow, eDrone, a CRM platform for e-commerce companies. What I love is they have 40 operational procedures that they've implemented in Lambda. So these are repeatable little microservices that they can use within their organization. And it costs them $3 a month. $3 a month. I mean, the cost of some of these services is mind-boggling just how cheap they are. It's amazing how many big brand name companies that you would recognize on a day-to-day basis are using Lambda, and they haven't even broken out a free tier. It's costing them absolutely nothing. So if you want to get started and experiment with Lambda, I really, really encourage you to do this. It's a great way to get started and see how this new world works. But as you start building microservices, you start thinking, well, how do all these microservices start communicating with each other? Because as these start communicating, not every microservice has to be based on the same framework or technology. You could have, for example, have a .NET applications talking to J2EE apps, Node.js, whatever you like. This is the beauty of microservices. They interact with each other via APIs. So as you go through this, what's needed is I want to have consistent communications management. I want to have the visibility as to what's happening across the entire stack through services such as X-Ray, for example. I want to have failure isolation and protection. What happens if one of my microservices has failed? I don't want the entire application experience to stop. I want it to intelligently work its way around that, for example. And I want to have fine-grained deployment controls and models so that as different developers update their microservices, they're not impacting other microservices being run by other teams. In Amazon, we call these the two pizza teams. These are very small teams that have strong ownership of their individual services. And so when you look at this, we thought there's a service that will help developers manage these very large microservices-based environments. And this is where AWS App Mesh comes into play. It's application-level networking for all your resources. So what you can see here is there's a collection of microservices underneath, and App Mesh allows you to simply define rules for service-to-service communication, and everything else is handled automatically. You can use it as a single point of control. Instead of trying to manage each single microservice independently, you can get a complete holistic view end to end. You get observability across the application, allowing you to easily pinpoint errors that may be occurring. Again, this becomes important. Some customers are running hundreds upon hundreds of microservices. So being able to find and pinpoint quickly and before their customers notice there might be an issue trending, they can identify it and fix it. And then you want to have granular traffic control so that I can reroute traffic in the case of failures or when code changes are needed. For example, I'm doing an upgrade of one of those microservices. I can disable that piece of functionality, route around it automatically, and continue working. So this sophistication gives you great power as engineers to create highly resilient applications based on microservices architectures. Okay, so if you've got microservices, you want to be able to have continuous security because, again, things are changing really quickly in this dynamic world. Changes are happening sometimes multiple times per hour. In Amazon.com, we make a change to that website on average kind of every 11.6 seconds. To give you an idea of that frequency. So security in that constantly changing world is important. You need to be able to protect your customers in that. And so if you think about the new security team that you need in this type of world, you have operations, you have engineering, you have application security, and you have compliance. But at the core of all of this is you need to have development. I'm actually a big fan of your security teams should have developers in the security team. And your development teams should have security specialists within the development teams. Bringing these skills together increases the security posture. Because if you do this, security becomes everyone's job. And this is absolutely key to what I said earlier about security has to be at the foundation level. Every single one of you in this room has a role to play when it comes to security. You can't just hand it off to somebody else and trust that they are going to do their job to keep you secure. You have a role to play in this. And in cloud scale security, you can think about this in a number of ways. First of all is you need infrastructure as code, which is your base requirement. You want to have elastic security automation. This is really critical. In cloud, your resources are scaling based on that real-world demand. It can grow tenfold within minutes. You don't want security becoming a choke point. You want to have a security posture and environment that scales automatically as your compute, storage, and network needs grow as well. You can imagine in the world of gaming companies, when they launch a new game, they go from 0 usage to sometimes 1 million+ customers within an hour. And if they miss that opportunity, they don't get a second chance at it. And so security is critical to that scaling. You want to have runtime security, using tags, for example, to identify what is what and be able to do continuous penetration testing of those resources all of the time. And then I want to have immutable infrastructure, validation enforcement, and integrate with managed services across from AWS. And so what this looks like from an automation point of view, to give you an idea of some of the services that back-end those capabilities, for example, Trusted Advisor. It gives you recommendations on where you may have configuration errors that may be exposing you to security risks, such as, for example, a public bucket in S3 with data in it. I can use AWS config to define rules as to how my AWS resources should be configured. I can use Macy, for example, which uses advanced machine learning heuristics to try to model the data that I have stored, looking for things like personal identifiable information, credit card numbers, etc., and give reports on why the information model may not being applied. Now, there's lots of services there, but one of the other big shifts has been, in the past, encryption came at a cost. You know, remember the old days, you had to make that trade-off. If you wanted to run encryption, it was going to take a massive need on your compute and performance would suffer, and we used to do things like offloading in the network layer to try and give us a boost, all those fun old engineering tricks. Well, the good news in today's world is encryption is included for free just about everything. It's a first-class citizen. And what this means is there's really no excuse not to encrypt your data anymore. It's best practice to encrypt everything and be really actually quite pessimistic about who may have access to it. And if you do these services, this is why security is everyone's job. If you're a developer, you should be thinking about what the security posture is going to be. Even if you're just a consumer or you're a business leader, you have a role to play in asking the right questions. How have we secured this? What regulatory compliance do we need? How are we earning customer trust based on the technology decisions that we make? So to dive into this in a little bit more detail from a customer perspective, Monitor Money Bank. They're the 4th largest bank in the Czech Republic, and they've migrated highly regulated financial services workloads to AWS. It's my pleasure to welcome to the stage the CIO of Monitor Money Bank, Vladimir Klein.
Good morning. Great to be here with you today. Can you imagine 2 years ago having bank data in public cloud infrastructure? In Czech Republic, that would be not possible. That was one of my first tasks when I joined the company to change. But before I dive into cloud story, I would like to give you a very quick overview of the Moneta Money Bank, because might be not known for you. We serve 1 million customers in Czech Republic, mainly consumers and entrepreneurs. We don't care about big corporations. We generate 400 million revenue in euro per year. We have more than 3,000 employees and slightly less than 190 branch offices. We are close to 30 years on the market, but in 2016 we rebranded, we were publicly listed, and we are a fully independent bank in Czech Republic. Why we moved to the cloud? We decided that we will digitalize our product services for our clients with ambitions to be digital leader on the Czech market. However, our infrastructure, data center infrastructure, was quite old and not always performing in the best way. And for parallel agile development, we needed infrastructure to be like very quick, automated, on demand, scalable, which we could not do in our own data centers. Then we decided to decommission our old data centers. Legacy system, we moved to the hosted data center, like for example, mainframe, which I still have. And other applications, we are moving to AWS. We choose AWS because of breadth of the services and very good support of open source technology, especially if you are looking to like automation of development lifecycle, CI/CD, that's like a lot of applications which are available at AWS. We decided for Frankfurt region because we have to stay at the European Union space due to regulation. For high availability, we have 3 availability zones, and we use different virtual spaces to segment production, testing environments, and security platforms and elements. Because for banking or financial institutions, data privacy is the key, then we encrypt our data at rest, but we are using our Moneta key, which we encrypt data that even like Amazon employee cannot access our data. At the same time, we encrypt in transit, and we decided not to use network encryption like IPsec, but we encrypt like communication between front and back ends, database application platform, because we believe from architecture point of view it's better for the future. Key which we generate, we input to the AWS key management service that it can be used for encryption of our data. User access management and logging is the second top priority. We don't provide generic access. We set up minimum rights which are needed for every administrator. We use multi-factor authentication like username and password and token to identify, to simplify user access management. We did Active Directory federation that we can use our accounts which we use in the company. For our security monitoring center, we are collecting all alerts or what administrators are doing in the systems. We are collecting from CloudTrail and log buckets to our monitoring center that we have full history what was happening on our infrastructure. From the services, we are using for computing EC2, typically S3 for the storage, for some networking like DNS, load balancing. For testing environment, we are using auto-scaling functionality that is switching off during weekends, nights, and then developers can start environment at the morning. For database, we are using RDS from AWS Market Store. We are using, for example, for data lake bricks. And now we are in the process like starting to use containerization, which we plan to use, or archiving data, because as bank we are obliged to keep some of data for 10 years available. What I see as benefits for us, and I would strongly recommend to you, if you move to AWS, you have to optimize the traffic or load in the AWS. Because typically engineers, if they build on-premise environment, they always buy overcapacity for covering the peaks, or because buying one CPU or memory 1 year later would be very expensive, that they buy it at the beginning more. In the AWS, you do it differently. You start small. If you need, you scale it up. That we were able to optimize in the cloud our spend to AWS by 20% just by optimizing that. Second big benefit is the speed of the delivery of environment, because from business request to the delivery of the server, it takes in hours, but it's mostly time discussing between owner and infrastructure guy. Then really, because normally it takes just few clicks to make the server running. And you might even say, because I believe we improve the security, you might imagine if you have like data center where you have 1,200 servers, that we were running still like many servers with very old platform, which were even not supported by AWS, that we had to do like upgrades and patching there. Looking to say, I'm working like 25 years in IT and being responsible for data centers, I have to say that I never had so secure data center as I have today. Thank you. Have a nice day.
Awesome. Thank you, Vladimir. Perfect. All right. What about data at the edge? There's a lot of talk about edge networking. And what's this being driven by is the billions of connected devices that exist in just about every single industry, whether it be medical, planes, transportation, industry 4.0, agriculture, robotics. Everything's becoming connected in your homes. They actually predict there's going to be 75 billion connected devices by 2025. And so the part of this is having an IoT core platform that makes it easy for you to engineer solutions that allow you to work in this connected world. How do you do fleet management? How do you do end-to-end security of these devices that can be out there in the field? And so AWS IoT platform has many, many capabilities and services to allow you to manage entire fleets of equipment out there. Even if it's completely different and different services out there, it's quite easy to do. You can use FreeRTOS, for example, one of the most well-known real-time operating systems, for example, in embedded systems, for example. There's customers using this across all industries, as I talked about, but for example, Philips Healthcare, the machines out in hospitals and health centers, for example, they manage those as IoT services, and they're kind of storing and analyzing 30 petabytes of patient data gathered from over 390 million imaging studies, for example. So the use of IoT is at the core of digital health initiatives, for example, or in the utility space with smart grids and smart meters being used by Vantage Power, for example, to help with that. But if you're having all this new data, the reason you want this is so you can apply analytics over the top of it. And what we're hearing is that companies want more value from their data than they've ever had before. It used to be, not that too long ago, that we'd look at data and how can we delete it because it costs so much to store. But when you're using AWS and services like S3, it's incredibly cheap to store information, and the insights you can gain from that can give you competitive advantages that you've never been able to have before. And this is why cloud data lakes are the future. Why there's a big investment from, particularly in enterprises, to normalize their data and try and get a single view of their customer across business units, for example. And at the core of data lakes is Amazon S3. It's actually our oldest service in AWS. It's the very first service we launched all the way back 13 years ago, in 2006. And why is it so popular for data lakes? Well, first of all, it's got unmatched durability of 11 nines of durability, which is just incredible. It's got the best security, compliance, and audit capabilities for you to look at how your information is being stored, and is it being stored and managed correctly. It gives you object-level control at any scale. So you can apply these controls at a bucket level, which is kind of think of that as analogous to a folder, or at a per individual object, which gives you great finite control. It gives you business insight into your data using, for example, storage classes, where you can actually specify different objects are stored with different levels of redundancy, for example. But as you look at this, and you look at all these capabilities that S3 has, and by the way, you may have data sitting in other systems as well. You might have it sitting in databases. You may have it in other storage services. And if you take all of this, creating a data lake took organizations months and months and months of preparation work to even get started around what that design would look like. And so we've listened to customers and created AWS Lake Formation, which is a secure service that allows you to get started and reduce that time from months to weeks. And it helps you solve problems like, how do you identify data? How do you move it into that single data lake? How do I catalog and organize it? How do I clean it? So for example, if that data has personal identifiable information or financial details that need to be pulled out, it can help you with that. It enforces security policies in that data lake. Again, you may actually have multiple copies of that data at different levels of information. A raw version that's heavily protected with your customer information in it. You might have a depersonalized information set that is made more available within your own organization. You may even have public data sets that are based on the metadata of the information that you have there. And all of this allows you to gain new insights from this data, and these insights increase the value of these stored data. And so when you look at analytics in a holistic view, you can see over on your right-hand side, we talked about the data movement. How do you get data there in the first place? In the data lake, you've got S3, Lake Formation, AWS Glue, which allows you to glue the different services together and pass data between them. You have the analytics engines such as Redshift for data warehousing and business intelligence. You have Athena for running queries across the data that you have in S3, for example. And there's also machine learning with Amazon QuickSight and Amazon SageMaker, for example. But if you look at Redshift, Redshift is a petabyte scale data warehousing tool from AWS. And allows you to pull data from different sources together. It's highly scalable, it's simple and cost effective to analyze all your data. And it's the most popular cloud data warehouse with more than 10,000 customers using Redshift to process more than 2 exabytes of data every day. The scale, again, of what customers are using these AWS services for is incredible. It allows you to do complex queries across large databases. And what I love is that we're continuing to innovate on the performance characteristics, because as customers' data sets grow because of these more connected devices, at the same time, we're increasing the speed of Redshift. It's 10 times faster today than it was 2 years ago, so it's able to deal with these increasing data volumes as things go through. Another big shift in analytics is the days of batch processing and having to wait to end of day, end of week, end of month reporting to see what had happened. What's the point of that? If you have to wait a month to get an insight, you've lost the opportunity to make a corrective action. And so you're seeing this drive towards real-time analytics, where I've been able to take data and do streaming analysis so that I can make decisions based on real insights as they happen. You see this in call centers, you see it in media, social media, advertising businesses, gaming technologies. And so there's a big selection of choices here. You can have Kinesis video streams, for example, where you want to be able to consuming lots of video streams from cameras, sporting events, retail stores, for example, data streams through Kinesis. Kinesis Data Firehose, how do I take these real-time data streams and stream it into a data store such as S3? Data analytics for doing a streaming analysis of what is happening, what's the min-max that I'm seeing, for example, in the last 10 minutes. Or if you're using Kafka, which is a very popular open source tool, how can I use streaming for that as a managed service from AWS? So as you look at this real-time streaming, you can do more with it though. And this starts leading towards one of the biggest changes that's happening in our industry right now, which is machine learning. Because as this value of data increases, our ability as humans to work with it and find patterns, provide predictions, gets harder and harder. But for machines, they're really good at identifying patterns, behaviors, predictive models from massive amounts of data, whether it be historic data that's been built up over decades or this real-time data that's being streamed in as it goes. And at Amazon, we've actually have a long heritage going back more than 20 years. For example, those of you who use Amazon.com know about the personalized recommendation engine, which started with books. If you like these style of books, we suggest these. And then we looked at our fulfillment automation as we started looking at how do we actually deliver packages to customers in an hour or 2 hours in certain cities around the world. It requires a lot of machine learning and AI behind the scenes to ensure we have the right products at the right fulfillment center at the right time for customers. And it's amazing just when you dive into that, how it shifts on a seasonal basis and even city by city. Prime Air, the drone delivery, for example, last mile delivery, heavy use of AI and ML for computer vision, for example. Amazon Alexa with voice-driven interactions. We're going to come back and talk about voice in more detail. Or Amazon Go, which is a retake on the retail experience, which is what if you can take the fusion of computer vision, artificial intelligence, and retail and merge those together so that as a consumer, you don't have to line up to pay with your cash or credit card when you leave a store. As you enter the store, it uses facial recognition to identify who you are against your account that you already have. We use IoT to detect what products you take off the shelf while using facial recognition to understand that was Glenn who took that, and then you just walk out of the store. The original premise behind Go was how do we remove the queue when you exit? Ironically, we created queues how to enter because it became so popular as you go through with this. But underlying this is the philosophy we have at AWS, which is how do we put machine learning in the hands of every developer and data scientist? Because while universities are getting better and better at creating data scientists and machine learning engineers, it's not enough for what we as an industry need. The demand for machine learning expertise is incredible. And more machine learning is happening on AWS than anywhere else. For example, with offices in Poland, UK and the US. Applica.ai offers a robotic text processing solution that automates processing of text documents. For example, if you think about 300,000 complex legal documents per month while complying with global security standards, that's incredibly complex to do. But something if a machine can learn how to do, can do it at scale. And with Applica, they're able to use this to reduce the document processing time by up to 90% using machine learning and artificial intelligence. There's lots of examples here. I'll give you some links at the end to go into this because there's lots of good examples here. So when you think about machine learning and artificial intelligence, the way we like to think about it is it's got a 3-layer stack. At the bottom, you have the frameworks and the infrastructure, which if you're a machine learning engineer, gives you the ultimate control, but also requires the highest expertise. In the middle, you have ML services such as SageMaker, which is great, for example, data scientists who want to deal with data and training of models, but not worry about the underlying infrastructure. And at the top, you have the AI services themselves, where you may be a developer who has no understanding of machine learning models. You just want to take the benefits and apply those within your business, for example, through the use of an API. So let's have a look at the infrastructure layer. For example, we have the P3 instances, which give you huge amounts of performance, 100 gigabyte networking, which if you're training large models, which can be measured in petabytes in size, you want to have fast networking to ingest that data into the instances. The largest instance type, P3, DM, 24 extra large, like code words, isn't it? But it's the largest GPU instance available anywhere in the industry. And it's got 3 times faster network throughput than other providers. If you start looking at what's happening on this infrastructure, though, is you have the frameworks and interfaces that developers are working with, TensorFlow, MXNet, PyTorch, for example. And if you look at what's happening with TensorFlow in particular, which is a very popular framework, it's one of the easier ones to get started with and has kind of the most community built around it. It's a platform of choice to run TensorFlow. Actually, 85% of all TensorFlow workloads in the cloud runs on AWS. For example, Siemens run their natural language processing model to expedite due diligence on energy projects with TensorFlow on AWS. Beth Israel, teaching hospital of the Harvard Medical School, is building a model to accelerate identifying consent from patients and reviewing patient medical records. Or Snap, the makers of Snapchat, they built TensorFlow models on AWS to better match ads to users to maximize their revenue and engagement, for example. So lots of different use cases that people are using. But when you use TensorFlow and some of the reference code supplied by this vibrant community, and you start running and training larger models, you start running into a scaling problem. And one of the scaling problems is TensorFlow, it doesn't scale linearly. And so if you think about where you have 256 GPUs that you're using to train this data, for example, the efficiency of utilization of those 256 CPUs is only 65%. But at AWS, we looked at our engineering teams, and I optimized TensorFlow so that it does scale a lot better. And at the same case, now I can get 90% efficiency using TensorFlow and the same number of GPUs. So this gives you huge performance savings as well as cost optimization savings, because otherwise you'd have to keep adding more and more CPUs as you go through this. So this is great for training, but what about inference? And so in the world of machine learning, those of you who aren't working in it, you may kind of think about it as there's models. We have data that helps us train those models, and once those models are trained, when we apply things, for example, on Alexa, when you talk to her, and she's listening to the conversation and interpreting that, that's called inference. And often, most customers would be training a model maybe once or twice a week. But with inference, you're doing that thousands of times, if not millions of times per week, because that's the actual application of it. And so this is where the real cost comes in, is it's in inference as you go through with this. And so we looked at this and thought, well, there's ways that we can optimize and bring the costs down for customers as their use of machine learning continues to scale. For example, you can use some of our standard EC2 instances, like an M5 instance, and attach GPU capacity to it in smaller amounts. And so this allows you to optimize what amount of GPU you have against the compute capacity you have. And then we're taking it a step further with Inferentia, which allows you to use custom hardware from AWS that we've designed that will lower the cost by another 75%, or actually tenfold from what Elastic Inference will have. And so this is coming in late 2019. It's going to be incredible, particularly where you're running industrial scale machine learning in the cloud. And coming soon, we also have the G4 instances, which have the latest NVIDIA T4 Tensor core GPUs. It's going to have faster local storage and 100 gig networking as well. And this is going to be available in just a few weeks. So again, you can see this inherent need for high performance infrastructure to run these machine learning workloads. All right, what about SageMaker? SageMaker is very, very, very powerful tool. It's one of the easiest ways to get started with machine learning. And you can really think that it does 3 tasks. The first task is it helps you with building out that machine learning model in the first place. You can use Jupyter notebooks, for example. You can pick which models that you want to use, and there's a great selection of them. And these algorithms have been optimized. Sometimes they're 10 times faster than what you can get in other platforms. I then can train that model using, for example, SageMaker Neo to optimize that model to get significant performance gains as we go through this as well. And then once I've trained that model and I'm happy with it, I can deploy it to production with a click of a button and not worry about the EC2 instances underneath that. SageMaker will take care of everything from the building to the training to deployment. And there's lots of hidden services in there that are quite powerful in their own right. Ground truth, for example, allowing you to annotate your training data using machine learning can help. There's more than 10,000 customers using SageMaker all the time. Secure and Pay, for example, payment platform with offices in Poland and Switzerland. They're using Amazon SageMaker to train machine learning models to detect fraud and make it possible for merchants to decide whether to decline a sale in near real time, for example. If you remember, you used to have to tell your bank if you're going overseas only 5 to 10 years ago. And then they got better with their fraud detection, and they'd give you a call a couple of hours after that maybe suspicious activity had happened. These days, it's real time. They can kind of block individual transactions in real time based on some of these transactions. Secure and Pay is actually doing this and scoring 60 transactions per second at the moment through their platform. Formula One. They're making heavy use of SageMaker. If you watch a Formula One race now, you might see the F1 Insights, which is powered by AWS. And this will give you insights into, for example, should the Formula One driver pit now or later? How's the car performance? What's the overtaking strategy right now with predictions as to whether they're going to be able to overtake on the next corner or not? That's using SageMaker to do predictive modeling, for example. And then at the top layer in AI services, one of the biggest areas is around vision, using, for example, image recognition and video recognition to look at the metadata and say, is this a dog? Is it a human? Are they wearing glasses? Are they happy? Are they sad? Is there a tree? Image recognition is really important, particularly for media companies, for example, which may have massive libraries of images going back up to 100 years, for example. Textract. Using OCR to extract information from documents. One of the things Textract does, though, using advanced machine learning, is it can understand things like tabular format, graphs, and other complex data structures, whereas OCR traditionally could only deal with very simple sentence structure, for example. The other thing we heard from customers was, how could we take some of the Amazon technologies used within Amazon.com, such as our forecasting tools or our personalization tools, and make that available to customers? And so we've announced both of these capabilities in December last year, and they're in preview mode right now. Amazon Forecast, which gives you accurate time series forecasting service, and Amazon Personalize, which gives you real-time personalization and recommendation service based on the same technology that we use at Amazon.com. And then last but not least What about speech and language? Chatbots have become very popular for good reason. And the ability with chatbots to start doing things like, for example, I can deal with different languages. What if I want to translate from English to Polish, for example, Polish to English? If I want to comprehend the meaning behind text data, and even extend that into particular vertical industries, such as the medical field, and say, when I read a medical document, I actually want to know, what is the medication? What's the dosage rate? What were they trying to treat? And other specific fields of information that are specific to the medical industry, for example. But one of my favorite services is actually Amazon Lex and Poly, which deals with turning text-to-speech and text-to-speech and speech-to-text back and forth, for example. And some of the technology that underlies Poly. But what you might not realize is that Amazon Poly, which supports 59 voices in 29 languages, is actually developed right here in Poland. And with that, it's really great to have our Director of Engineering for this service, who's based out of Gdańsk here in Poland, here on stage with us. Please welcome to the stage Rafał Kukinski, Director of Amazon Text-to-Speech.
Welcome, everyone. I'm super excited to be here. It's super excited to be part of the first AWS Summit in Central and Eastern Europe. As Glenn mentioned, Rafał Kukliński, I'm a director of Amazon Text-to-Speech. I'm also a site lead of Amazon Development Center Poland, which is based in Gdańsk. So let me start with a short introduction about Development Center in Gdańsk. So we started, or Amazon Development Center in Poland started from the acquisition of a company called Iwona Software in Gdańsk, something like 6-7 years ago. Since then, for the last 6 years, we grew from a team of 24 people to over 600 people working in Gdańsk, and keep growing. We keep growing, and we are right now a home for scientists, machine learning engineers, software developers, data engineers working on variety of technologies from text-to-speech, natural language understanding, speech recognition, building on-device and automotive solutions. We are working on products like Alexa or AWS machine learning services, specifically Amazon Poly. We are also quite active in the local engineering scene. So we host hackathons, we host meetups, we host our local conference called Innovation at Amazon. Next edition this September, by the way, you are all invited. But today I would like to focus on the technology which I'm most familiar with, which I'm an expert in, specifically about speech synthesis. So speech synthesis itself is not a new technology. Let me play you a video.
Let's see how you put expression into a sentence. Say, she saw me, with no expression. She saw me. Now say it in answer to these questions. Who saw you? She saw me. Whom did she see? She saw me. Did she see you or hear you? She saw me.
I love this video because it also presents how important is the stress and accent in the sentence to pass the right information, to pass the right semantics of the text. This is a Voder system from 1939. So as you can see, speech synthesis and speech technologies are known for decades. But what has changed over the decades is the quality of the systems that we are building. And what means quality in terms of speech synthesis? So one thing which is critical is accuracy of text interpretation. So how well speech synthesis system is capable to understand the input text, understand acronyms, abbreviations, numbers, and simply expand them correctly. Second critical element, as this video also shows, is the naturalness of intonation. So how naturally we are intonating, how well we are predicting where to put stress in a sentence. And last but not least, high fidelity of speech makes speech really natural. And the element which changed everything, which made a huge progress for us, is obviously deep learning. So in fact, for modern speech synthesis systems, there are right now 3 foundational elements which are critical. First are powerful machine learning, or I should say deep learning algorithms that are running on effective and efficient frameworks like MXNet, for example. Second, obviously, is abundance of data. Data is critical to train the models and build models which sound naturally. Last but not least, massive computational power available on AWS, like mentioned P3 or soon AWS Inferentia instances, is critical to run those huge networks in real time. What it gives us is obviously more capabilities, so more natural and more matching the cases speech. I will give you two examples of those capabilities that we built and we are working on and we released recently. One of it is newscaster. So what we did, we realized that for some types of content, we need a specific speaking style which matches the content, which matches the way how this type of content is being provided. So mimics the real newscaster speech. Let me play you a sample.
San Francisco's $2.2 billion Grand Central Terminal open. Spanning 3 city blocks, San Francisco's $2 billion transit terminal is open after nearly a decade under construction. Coined the Grand Central of the West, the new Salesforce Transit Center near the heart of downtown is expected to accommodate 100,000 passengers each weekday and up to 45 million people a year. It welcomed its first passengers and visitors this month.
Great news for San Francisco, by the way. This is a speech synthesis systems, and in our blind test that we performed with thousands of people, this system is non-distinguishable. The speech is not distinguishable from a real human being. Let me give you a different example. So recently, we also released for Alexa and for Amazon Polly a capability to whisper. So in context of Alexa, I might think about the situation when you enter your home late in the evening, you are trying to set up an alarm for the morning, and you do not want to wake up everybody around you. So you would like to whisper to Alexa, and you would like also Alexa to whisper back.
Alarm set for 7 a.m. tomorrow.
Of course, whisper works great with sleeping room, not specifically for a venue of 2,500 people, but you get the point, I guess. So there are obviously more capabilities, and they all add up to the power of speech. Speech is powerful. Speech is an enabler. When you think about, for example, accessibility, we work with Royal National Institute for the Blind for years, delivering speech synthesis to make devices and content available to people with visual impairments. Just recently, RNIB also released the huge library of ebooks available for almost 2 million of people in the UK with sight loss. For those people, speech synthesis is a way and is the only way to consume content and enjoy ebooks. This makes this content simply available to them. This enables them to consume that. Another area which grows and which adopts speech because of the latest advancement in the speech synthesis is publishing. For publishers, it's critical to pass the information and make sure that the way the speech synthesis works with news articles, it delivers the compelling experience and allows people to lose themselves in the content. So right now, with speech synthesis, with publishers entering this space like Politico, it's possible to build a system which simply democratizes access to information. When you think about it right now with speech synthesis and with voiced articles, it's possible to consume content while we are on the go and commuting to work by bike or by car. It's possible to consume content where your hands are busy in the kitchen. So simply gets the access to the information for everyone. Obviously, I should also mention Alexa. So latest advancements in deep learning made Alexa possible. So when we started working on Alexa, the initial idea was to build a computer which is available for everyone, available everywhere, and capable to do everything. That was the initial idea. And it's an Amazon style to start about thinking about specific experience from a press release. We prepare a press release defining the ultimate experience, and from this experience, we are working backwards to define what kind of product we need to build to meet this demand. And that's how we got to speech, simply because our brains are wired for speech. As human beings, we are we learned how to speak something like 600 to 200,000 years ago, while we learned how to use computers something like 100 years ago. Speech is simply natural for us. Mouse, keyboard, touch screen are great interface, but those are just proxies creating additional friction, requiring us to learn something. And we learn how to speak from our earliest days, from the very beginning. That's our way of communicating with the external world. If you would compare it to the humankind evolution, computers are great. Touchscreen is already a simplifier, but still you are spending over 3 hours daily on your touchscreen, and you can speak up to 4 times faster than type. Really, speech is the natural interface. What comes next with Amazon Poly? We keep working in Gdańsk on Amazon Poly in various dimensions. We'll bring new voices and languages. We will be working and are working on the speaking styles that will be matching the particular types of content. We'll be working on the intonation patterns to match semantics, so meaning, and sentiments on emotional content of the text. So as we used to say at Amazon, it's still day one for us. Thank you.
Thanks, Rafael. Awesome. So, if you're thinking of this and thinking, wow, machine learning sounds amazing, it can do incredible things, and it's touching what we do on a daily basis. But how do I get started in the world of machine learning? Because it can be a little daunting when you first hear about it. There's all these complex talks, and you're thinking, maybe I have to be a mathematician or a statistician. You don't. It's actually relatively simple to get started with machine learning. It's just to have to take that first step. And so we've been looking at how do we help customers jump into this exciting new world of machine learning. And we have a couple of ways to help you with this. First one is the Amazon Machine Learning Solutions Lab, where we pair you up with some Amazonian experts in this space, and we help you everything from brainstorming, how can machine learning help your organization, then what is the modeling that would be required to achieve what that brainstorming session came up with, and then actually deliver a proof of concept as a result of that. So that's one of the easiest ways to get started, where you're kind of holding hands together and using experts to help you. But if you're a self-learner and you prefer to learn things on your own, that's okay as well. There's the Amazon Machine Learning University, where we take the same content that we deliver to thousands of our own software development engineers in Amazon, how they learn to become machine learning engineers as well. And so you can do this online. We also announced the AWS Certified Machine Learning certification, which is a way for you to not only learn, but prove to others that you have knowledge and expertise when it comes to machine learning. Now, one of the areas that often comes up when people want to learn machine learning is computer vision. It's no surprise, vision is one of our most powerful senses, and the amount of information you can take from a visual source, whether it be an image or video, is intense. But if you've ever tried to get started with computer vision, it's pretty complex. You need cameras and hardware and software, and just getting it all so it works can be an exercise in futility sometimes. And so we worked with Intel and created the AWS Deep Lens, which takes a lot of different technologies and packages it together into a single device that allows you to get started with computer vision models really simply. Actually, you can get up and running within 10 minutes. You can use SageMaker, for example, to train a new model to recognize different objects. Is this a unicorn or not? Is it a motorbike, a car? Whatever you like, and start testing these services of SageMaker through to Deep Lens using edge computing and Greengrass and some other fun technologies, all in a single device. But we didn't stop there, because one of the other things we thought about, well, what if we took Deep Lens and gave it wheels? And so we created Deep Racer, which is a great platform being used in universities and companies of how to get hands-on with learning of machine learning, because we all roughly know how to drive a car, we think. And one of the great things about driving a car around a track is it's a great model for reinforcement learning, where I can give a score on how well the car has taken that corner or achieved a lap time around that track. It's a really easy, intuitive way to learn about some of these models. But if you've got a car, let's race them. And so we created the AWS Deep Racer League, which is the world's first global autonomous racing league. And what you can do is you can go online, you can actually race this virtually. There's a virtual environment and a virtual league where you can train your models, you can run it around the racetrack, see the results, play with the reinforcement learning, the scoring, for example, and see if you get a different result. Now, if you get a good score, which is a lap time, the top winners from around the world will get to go to reInvent later this year and compete in the global league for that. And I reckon there's a couple of people in this part of the world that would give it a really good shot. I'd love to see some of you on that leaderboard and giving the rest of the world a shot for its money. The world record at the moment, I believe, is held by Korea. So give them a good challenge as it goes. Now, I know there's been lots of information that we've drummed through really quickly. A really good website to go to get more information. There's white papers, there's customer testimonials, there's the hands-on labs. Go to ai.aws and you can find out more information there. There's great partners just out those doors who can help you as well with your journey to AWS. There's lots of breakout sessions available to you. One of the biggest values of these summits is actually the networking amongst all of you. All of you have incredible insights and experience. Talk to each other, ask questions, and apply it. And with that, there's never been a better time to build. So let's build. Thank you very much for having me. Enjoy the rest of the day.